I am the part of the Econopure water system for the desals team. We introduce it here, but three parts. The first part, we introduce the concept of one of those module in here. This one is a 2 cubic meter per day module. We designed it before, but because the requirement of the groups later on that we need to get a full scale, so we are going to design a full scale system with a 20 cubic meter per day, but we will run only 10 hours to produce about 8.25 cubic meter is the requirement by the descent tube. Then downwind will be introduce the part of the evaporator. That is the very essential part of to become the zero liquid discharge for this particular unit. So here is the concept of using RF nano membrane to clean up the water enough for the requirement for the desals group. This one will produce a 2 cubic meter per day and use a 4-inch module. In order to do that, we have to open up the spacing between the membrane to make sure we have the adequate enough crossing velocity, and to provide the pump. This pump will provide about 35 gallons per minute. That will be produced at 2 feet per second of cross-flow velocity across the membrane inside that filter module. That 2 feet per second velocity is very essential to keep on those precipitation like a sulfate calcium and a sulfate magnesium and calcium magnesium in suspension without precipitant on the membrane itself, and then eventually will be removed by the hydrocyclone, and from that go into the evaporator. So we have a feed pump in here. Will produce the pump, the high pressure for the entire system, and we have the regulator and the sensor to make sure that we adequately to record everything happening during that. And then the permit line right here, we have some special. This will have a control panel to close out that thing. It provides, we call it rest cycle. That in this particular rest cycle, the velocity will increase inside the recirculation to make sure that on those the surface we have clean. Now I would like to introduce Patrick to talking about the full-size module.
Okay, I'm Patrick Salcedo, and I'm going to talk about our full-scale system. As you can see here, it is 2 vessels, 2 8-inch vessels, and is capable of doing 20 cubic meters per day, running at 24 hours. We are waiting on a little bit of piping, but the concept of the large-scale system is the same as our small-scale system. So you can see here we've got the recirculation pump, which is the same as the small recirculation pump. Just does a higher capacity of 150 gallons per minute, which is necessary to keep the precipitate in suspension, both during rest cycle and during run cycle, just like the smaller pump. The reason for that is it's a larger scale, larger area, so with that we need the larger pump. And in the back there you can kind of see our feed pressure pump, which is going to be providing the high pressure for the entire system, both the vessels and the hydrocyclone here. And the diatomaceous earth is going to be injected upstream of the pressure pump and will then be continuously fed into the system at our 3 mils onto the membranes. And here in front we have the hydrocyclone, which is going to take about 10% of the recirculated flow controlled by orifice, and will help separate some of the precipitate from the clean water. The other 90% is going to be controlled by the orifice, and it's going to come out on our permeate line, which will be coming out through the top and down to the bottom to our clean water tank. And here you can see our control box, which is exact same concept as the small scale. It will log all of our data, our flow, pressures, and it will automate the entire system during its runtime, and will automatically set it into its rest cycle, where we, as BM said, we close off our permeate line and our feed line, and we run the recirculation pump here at a very high speed, and so we can get 2 feet per second inside the 8-inch vessels there. And it helps to clean the surface of the membranes, keep everything suspended, and then we can continue our run after that. And so we have 10% of our water coming out of the hydrocyclone, and from there it will go over to our evaporator. And to talk about our evaporator, I will introduce Don Quinn.
Hi, this is Don Nguyen, and the evaporator here is a demonstration scale, 1/15 of the real system, that they can carry the full charge. Essentially, it includes a felt serpentine through a series of roller at the top and roller at the bottom. The felt provides the surface area for the concentrate slurry to be dried. And the felt is motorized by a pendulum weight, which moves the felt in very slow movement, roughly about half an inch to 1 inch per minute. Concentrate coming from the filter module will be sprayed on top of the felt. Whatever pick up by the felt will be retained and circulate until being dried. The leftover will be collected at the bottom pan of the concentrate, and being as the felt running, it swipe the bottom of the concentrate pan and pick up the excess amount of concentrate and continues the drying and all evaporation part. The felt create the pocket in betweens, and in order to improve the drying rate, pocket ventilation system, which is using a forced air to reduce humidity inside the pockets that are formed by the felt layers to enhance the evaporation rate. Thank you very much, and I hope that you have an idea of the whole system.